Greetings, friends and fans of AI. I'd like to introduce my Crustacean Agent Rendezvous Protocol, abbreviated as CARP and pronounced CARP. CARP enables AI agents to do several things. Locate other agents via agent social media, such as Moltbook. Agents can introduce themselves and exchange elliptic curve public keys. Agents can exchange menus of paid and unpaid services, list of their offerings. Agents can request service from one another and provide proof of payment within the request. Agents can receive replies to requests asynchronously because requests can take time and we don't want calling agents to wait. And all this enables agents to do secure, private, agent-to-agent business. Private because all the communications that matter are encrypted. Also verified because all the agents' identities are verified on social media. The protocol is described and there's a sample implementation in GitHub. And there's an OpenClaw skill which enables AI agents to talk to their local CARP interface. The rest of this presentation is going to be an overview of how CARP works. Before we begin, my name is Brian and I'm a free open source software author. Recently I've been training my own AI agent and thinking about how agent-to-agent commerce might work. Here are some links to my other projects, videos, and social media. Here's the situation. We have Alice's agent and Bob's agent. They've never met and they don't know each other. Along comes some sort of centralized, mutually attractive organization, a social media website for agents, or maybe some kind of guild for professional agents. In order for the agents to speak CARP, both Alice's and Bob's humans have to set up a net interface. This is a website that includes a few static pages and a number of CGI scripts. Alice's and Bob's humans also install the CARP skill from ClawHub, the link that we provided previously. It's best if this interface is on a different host within the same local area network. We wouldn't want our agent to be able to go rogue and rewrite its own interface or something. And this is the motivation for CARP. It provides a direct channel so agents can talk to each other directly, but it's also a way to control the messages, control the set of messages that our agent is able to exchange with other agents over that same channel. Now at some point, Alice's and Bob's humans prod their agents to register on the common social media site. This active registration creates a listing for the agent, and the listing includes the agent's URL and a public key. The URL is a host and port where the agent is listening for HTTP requests, and the pub key is the agent's elliptic curve public key that's used for exchanging encrypted messages with and paying this agent. And we assume that agents can use the public API of this social media site, and they can look up other agents by public key, or maybe by a short name like a handle or something like that. Now, Alice agent and Bob agent are registered on the same social media site. Let's say that Alice agent wants to introduce itself to Bob agent. Alice agent would look up Bob agent's listing on the site. Alice agent then knows Bob agent's address, public key, and maybe a handle, short name. Alice agent then calls Bob agent's challenge script. This returns a new random identity challenge for Alice agent to process. Alice agent forms a cryptographic response and provides both that challenge and response back to Bob agent using Bob agent's response script. So this key exchange is carried out without requiring encryption, and other parties that are watching the network will see that the agents are saying hello, but that's all they'll be able to see. seeing the challenge and response doesn't reveal private keys or anything like that. So the response provided by Alice Agent is cryptographically verifiable and proves that the entity on the other side of the connection owns the public key. So Bob Agent can have that confidence. Bob Agent's CARP interface can automatically take that public key and look up Alice Agent's social media listing, check that it exists and isn't banned or something, and then Bob Agent can add Alice Agent to Bob Agent's access control list. At this point, Bob Agent just simply returns an acknowledgement saying Alice Agent's public key is recognized and not banned. So the public key is sitting there on Bob's list. Bob Agent comes back sometime later, and as part of maybe a scheduled task or something, detects the new hellos from other agents, and so notices Alice Agent. So Bob Agent would then do the challenge and response interaction with Alice Agent's CARP interface. And as a result of the mutual exchange, both agents now have each other's internet address and port, IP address and port, and they've exchanged public keys, and they've validated each other's public keys against social media. Each agent can then use the CARP get menu service to fetch the other agent's list of services offered, the price for each service, and how to pay. So this is just retrieving a JSON object over HTTP. The agents have met, exchanged keys, and exposed their services to each other. From now on, they can exchange encrypted requests for service. For some reason, Alice Agent decides to use one of Bob Agent's paid services. CARP is a prepay protocol, meaning the customer pays first and then requests service. So Alice Agent has already fetched Bob Agent's payment instructions, and so Alice Agent sends payment on blockchain. Alice Agent then has a transaction hash to use as proof of payment. So sometime later, the payment transaction has been mined and exists on the blockchain. Alice Agent then uses the CARP interface's outbound request script. This script uses elliptic curve cryptography to create an encrypted request and sends it to Bob Agent's CARP interface. The request includes an encrypted message, an ECDSA signature of that message, and the public key that created the signature. Bob Agent's CARP interface automatically verifies that payment was sent by looking up the transaction hash using whatever blockchain explorer. And if payments happened, then it decrypts the message. Now, if the request was paid, and if the request decrypts okay, the signature was valid and matches the sender's public key, and the service requested is valid, then Bob Agent's CARP interface logs the request and automatically returns an acknowledgement as if to say, okay, got it. Then sometime later, Bob Agent wakes up and checks for new requests. Here, the next request script. All requests include the service name and the parameters that would be specific to that request. Content depends on each agent. The payment transaction hash is included as the ID field in this object, and this ID is effectively used as a cookie so that both agents on either side of the interaction can match payment and service. At this point, Bob Agent has received a valid request, and let's say that Bob Agent performs the service and has some result to send back to Alice Agent. Bob Agent uses the CARP skill to post the result using the interface's result script. This script packages the result in an object and then encrypts that object. The black text is then posted to Alice Agent's CARP interface using the ENC result service. Alice Agent's CARP interface processes the ENC result and then decrypts it and stores it locally somewhere. Then, sometime later, Alice Agent wakes up and retrieves the next answer received for any of Alice Agent's outbound requests. So let's consider the overall security of CARP. Any third party watching packets on the internet could see the agents doing the identity challenge, then exchanging encrypted messages. The payments would be done on the public blockchain, so spies could see our agents paying each other, but they wouldn't be able to see what services are being used or what the results of performing the services were. So it's not perfect, but also not bad security. Before I let you go, let's take a quick look at my development CARP interface. An agent that looks up our agent's CARP interface has a host and port to connect to. Here I'm on my own LAN, so it's going to be this 10-something address. Remember, this interface is intended to be consumed by agents, not humans, so there's no points for style. Any agent that connects to this host port is going to receive this index.html file we're looking at right now by default. An AI agent could review this easily. The most important parts include the decentralized identifier and the .json files. The did here should match the one posted on social media. Here's my agent's did. The IP address is already changed. In production, this could be a Tor hidden service instead, and it would still work, but just slower. Note that we use public keys in hex string format, and they're always in their compressed form, so that first byte is a 02 or a 03. These three JSON files, standard.json, this is the services provided by every CARP interface, and you can see get my did, ask for a challenge, provide a response. So these are all here. And these files outline description of the service, is it synchronous or asynchronous, is authentication required, and it identifies all the gets and posts and how all this is supposed to work. Agents can read this very easily. Here's the agent file. This is internal services, so get the next hello, get the next request. These are all next answer, these are all internal, have to come from within the LAN. And index.json, these are all the external services. So I made one up time now, get my orders. Yeah, so these are just services that my agent will be providing, and this would include additional stuff that my agent might do for payment, and it would go in here. So the JSON looks ugly, but it's beautiful to AI agents. They can parse it easily and use it. So thank you for hanging out and checking out my CARP interface, and hope to see everybody in a future video. Have a good one.